So we've just hit the top of the hour. Just looking at who is on. I think we have enough key people on to get started. And I'm going to wait for Karsten's audio to get on. And for my coffee to get hot, which just happened. So Karsten, are you on audio now? Okay, Martine can hear me. Karsten. Let me just check that there are no new slide requests. There are not. So still waiting for Karsten's audio. Karsten?
Yes, I just had to fetch a headset.
Okay, there we go. So thank you all for coming. Welcome to the CBOR interim session. Karsten, go ahead and hit it. It's your agenda.
Okay, actually the first point of the agenda is Lawrence's point, so I think
correct.
He can go ahead.
Hello, can you hear me okay?
Yes, we can.
And do you want me to share the slides? I'm not sure if I know how to do that.
I just passed slide control to you. You should be able to select which slides to show.
Okay, does it all look good?
It does.
Okay, so I made a list of things that I thought we were trying to address related to serialization that are issues in RFC 8949. It's been a while since that was published, and we've learned some things. I'm just trying to be helpful and productive here. I'm not trying to complain about RFC 8949. I don't know if I could have done better. So just working through making a list here. So as an intro here, this is really intended to clarify what we want to solve in CBOR CDE. Some of the issues in my list are addressed in CBOR CDE, some are not. I have no discussion of solutions here. I'm just trying to get the list out on the table. I'm really trying to bring everybody along in the working group to understand what we're trying to do here, and really kind of broaden the base of understanding here. I'd like to leave discussion till the end. So first, issue number one is that preferred serialization allows indefinite lengths. It's stated as a preference, not as a requirement or a must or anything like that. So that diminishes some of the value of preferred serialization. All the other things in preferred serialization are as a requirement. For example, always use shortest form. So I think that's one thing, number one, and this was the motivation behind basic serialization as an add-on to preferred. A little naming reminder, CDER is what I'm using as to reference what is written in RFC 8949. I am just trying, the sole purpose for me using CDER right now is so I can distinguish what is written in 8949 from what is written in draft CBOR CDE, because they are different. I feel a little silly that I didn't catch that earlier in this discussion, but that's the case. So CDER, and I'm just focusing on what's happening in 8949 right now. CDER references preferred serialization, and then it kind of goes on to restate them. So section 4.1 is in 8949, describes preferred serialization, describes it as a series of preferences. Section 4.2.1, which is about determinism, 4.1 is about preferred, 4.2.1 says we're using preferred serialization, and then it goes and restates most of the preferred serialization requirements in a normative form as a sort of a group, an aggregate to be applied all at once. There is a divergence between what is in 4.1 and 4.2.1 on definite lengths. That's the issue. Number one. So the upshot here is that implementers need to read both and cross-check just to be sure they've got it right, and prehaps this is not optimal. Number three. So preferred serialization puts requirements on big numbers, that is on tags 2 and 3, and you can see them, the text from 3.4.3 over there on the right. You got to get the leading zeros out, and you got to do a unification of the number space with big numbers and type 0 and type 1 integers to do preferred serialization of big numbers. Then in RFC 89 and CDER, when the preferred serialization requirements are restated, big numbers are not included. So my understanding is that the big difference between CDER and CDE is determinism for big numbers. That's number 3. Number 4. So if you go look through all the tags that are defined in RFC 8949 and understand whether they have variability in the data model, you find this was my list. For example, if you wanted to specify the date, midnight, January 3rd, 1970, with an epoch 1 tag, you can do it with a float, or you could do it with an integer. So there's 2 different data types you can use to use for that. Date strings are highly variable. Big numbers, we know that you can have leading zeros and things like that. Decimal fractions and big numbers also use big floats also use big numbers. So we find that there is data model variability in those tags. I mean, maybe I missed another tag or two, but that has variability. But so RFC 8949 gives you a preferred serialization for tags 2 and 3. RFC 89 does not give you determinism for tags 2 and 3. That determinism is added in draft CBOR CDE. Then, if you look at the rest of the tags, there is no preferred serialization or deterministic serialization for the rest of the tags. Seems like a gap worth discussing. And then last is what's the full and general data model for determinism? So in RFC 8949, there is some discussion of additional deterministic encoding considerations, but that is primarily around tags. It's not a general open discussion. It's just mostly about tags. CBOR is an example of data model determinism that is not just about tags. So it's clear that you can have variability in a data model of a protocol or a scheme or that is not just about tags. So that was the motivation for ALDR. So I see ALDR basically as a clarification of 4.2.2 or improvement on 4.2.2 or expansion of it beyond tags. So that's it for me. Thank you. I'll leave the slides up if we want to have some discussion here or other. Karsten?
Yeah, thank you. I think it's a good idea when something is nearly complete to revisit the objectives that we had there. And I think the main observation is that 8949 still was in this transitional stage where we didn't quite fully understand what the deterministic representation is. Yeah, it's a little bit hard to use. It's editorially not as accessible as it should be. There's one point where we seem to disagree. I believe that the core deterministic encoding requirements in section 421 do state that preferred serialization must be used. And preferred serialization is defined in section 4.1 for the basic generic data model and is defined in each tag for that tag. So section 343 is part of preferred serialization and is therefore normative part of 421. There's no other way to read that document. And I think that's pretty important that we don't think CDE adds anything there. It clarifies things and it does a few more things that makes it easier to use, but it's not an addition. Laura, do you want to say directly something?
Yes. The trouble there with what we said there is that 421 reiterates the preferred serialization requirements, and it states them as kind of a group. And in that reiteration, it does not mention big numbers.
Do you see the chat? Do you see the chat?
Yes, I see the chat.
I have copied the start of 421 and it says preferred serialization must be used, period. In particular, right. And now we are getting to the particulars, but that doesn't mean that this list is complete. So yeah, this is not a good way to write this. I completely agree with that, but it's not undefined. It's very much defined. So I think that's really an important observation.
I mean, the fact that what Karsten hasn't pasted in here is it says, in particular this means, and then it goes on to a bulleted list of all that restates all the preferred serialization requirements in a nice, clean, normative form, except the one for big numbers. So that's, from reading it from unless you're reading it as a lawyer, which really, really thoroughly, which you're going to miss it. So I mean, I think it's very ambiguous there and needs to be fixed.
It's not ambiguous. It can be misread, which is not good. Yep. And that's one big reason to actually write CDE. The other reason is in 422. But it's not undefined. It's very well defined. It's just that the in particular clause doesn't actually capture all the preferred serialization requirements. Okay. I think it's really important that we agree to that. Because if people actually are referencing 8949 in their documents today, like the CWT thumbprint, for instance, does, it's important that we understand what the meaning of that is.
So let me ask the question then, what's the difference between CDER and CDE? Why do we need a new name for something and a new concept for something?
CDE is a common deterministic encoding. Section 421 is a set of requirements that an application can choose together with choices offered in section 422 to define that application's private bespoke deterministic encoding. Now, fortunately, all applications so far, except for the early Fido, which didn't have the benefit of having this text, have done this in the right way. So they factually all use CDE. But 421 is a set of requirements. It's not the whole thing. It just is something you can reference as a whole in your normative document and say, we're going to use this now.
Okay.
So we have about 2 minutes left, I think. I wanted to quickly bring up the other point. There is a reason CDE doesn't touch tags 0, 1, 4, 5, and the other ones that you mentioned there. I have no idea how to do this in a common way. It's really different. So in particular, if you add tag 1001, for instance, which is in the same group as 0 and 1, different applications have different requirements there. So it's a better thing to say that's part of the application level deterministic representation rules than to say it's part of common deterministic encoding. So that's definitely true of 0 and 1. We can discuss whether we would come up with a solution for 4 and 5, but we have no experience in that. So I wouldn't feel very happy. We could update the INA registry to add a determinism column. Yes, we could do that. I think that's right now. This will look a little bit empty, but the point is not so much that tag 0 and 1 don't allow determinism, they sure do, but that the application has to make decisions that we cannot make for the application. So there are applications that need floating point numbers, there are applications that need integer numbers, and these two won't meet in practice. So it's really something that the application needs to decide. And yeah, most application data models that we have seen actually make a decision, for instance, completely excluding floating point numbers there. So that work is done. It's just not part of the common deterministic encoding because we cannot make that decision for the application.
So, Lawrence, is there further discussion you need to have on the mailing list about this stuff?
I have a lot of opinions about what Karsten just said, and I will bring them up on the mailing list and maybe have future slides and other things and all that. But I still have a lot of comments on this.
Okay. Good.
Yeah,
Well,
looking forward.
Yeah, thank you for the good review and for raising the issues.
Okay, so I pulled my slide set, assuming that was what you wanted, Barry. Yeah, so this is my usual matrix. Just to remind you, we just covered CDE. We will be covering PACT, and we will be covering EDN literals, and we will briefly mention EREF. We will not mention modules. So we have almost all working group documents in the meeting today, and unfortunately not the non-working group documents like Martin's DNS CBOR. Yeah, so we just handled this. So PACT, we did the working group call a long time ago. We said we wanted to get some implementation experience. IETF 121 had a hackathon that actually essentially achieved that. So the next thing we came up with was trying to get an early allocation of the tags. And that's where we ran into the discussion about consuming a lot of tags, in the words of Joe. And he's absolutely right in mentioning this. So the question really is not so much one about packed CBOR, but one about resource curation with respect to the good numbers we have. And the 158 is the interesting number because that's the number of 1+1 tags that we still have available. And Rohan, for instance, questioned my assertion we need to plan for decades, so we need to plan for the next 30 years. And Rohan said, well, maybe 50 years, and maybe he's right. So maybe we need to adjust these numbers, but I think the curation of this resource is going to be something very dynamic in the future. So we will update our views on this, just as we updated them when we did 8949 and looked at the consumption and found out that we were having a little of a problem here. Rohan.
I thought we had a concrete proposal in Bangkok to go with to start with the single tag approach, and that because we could add additional tags later.
Yeah, the problem with this proposal, and that's why I still think we need to decide something there, is that it actually shadows space out of the single tag reference mechanism.
I'm
which
sorry,
then
what do you mean it shadows?
The table, or we could do this differently, but right now the table is sorted by frequency of use. So the most frequent one is first, and then we get less frequent ones and so on.
Yeah.
And if we define this without tags, then we have to.
All right. So let's be crisp on the terminology. So if we define this by using a single 1+, if we define a single 1+0 tag, which contains an array with some identifier and then the value, we could go forward with that immediately, and that doesn't prevent us from later adding any number of other tags of whatever size we wanted to later.
No, but a part of the space is wasted because the existing tag already means something for these numbers. So you cannot use the short.
But it's one tag. So
No.
what you're talking about is concretely, potentially wasting one tag in order to save, whatever, a potentially very, 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 very large number of tags. So I don't think that argument is very compelling.
The problem is not on the text.
So,
it's simple values too.
Okay, can you join the queue, Vadim? This is not about one tag. So the referencing mechanism that is using the single 1+0 tag is of course not going to stand for the numbers that the 1+1 tags are already covering. So you push the
what do you mean already
usefulness. If we have 1+1 tags,
what
we
if
don't
we
need to have
tag which has an array of 2 items? That was a concrete proposal.
Yes, it's on these slides. I get to them.
Okay, so you're not I'm not hearing you making an argument for why that wouldn't work.
It would work. It would waste space.
So I think we could get rough consensus that everyone in this room, with maybe the exception of 1 or 2 people, are willing to waste a single 1+0 tag for that purpose, and it allows us to go forward. It allows us to go add those additional tags later if we want to, that don't require an array of 2 items. So I'd really like us to just get a rough show of hands and see if that's something that we want to go forward with, and then we don't
Yeah.
need to discuss this anymore.
A show of
And
hands is
we can
really,
come back
really
to it after we
more
have a few
useful
months
if
of
people
information.
understand the issue. So again, if we have 1 + 1 tags for certain numbers, we don't want to use the 1 + 0 tag for the same numbers. So we would shift.
Carsten, I think we all understand that. I think
Good.
we're willing, like the folks that like this approach are willing to accept that.
Good.
So we don't need to further discuss what the consequences are.
Good. Okay. It didn't sound like that was understood. So let me just move on. So there were several, just to understand what we are doing here, several ways of revising the draft 14 usage. For instance, by having 32. We have to talk about the inverted tags. Let's not do that right now. Having 16 1 + 1s, having 4, having 8, having 0. And I sat down and did some math, assuming a zip distribution, which maybe isn't
Wait,
that.
Carsten, why are we still?
Yes.
These slides have been presented before.
No.
This isn't an issue.
No. 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 I have presented a previous version of this slide.
But this is not the discussion. The disagreement is not about the contents of these slides.
Well, the question is not only about text, but also about simple values. Do your radical or not so radical solution leave 80% of simple values registered or not?
Okay. It looks like people don't want to look at these numbers. I think they are interesting because the radical approach can actually still be augmented by having a few tags. So we get rid of the architectural purity argument that is also out there by just having a small number of tags added to this. And I did the math of looking what's the result if we are not allocating the large tag spaces in 1 + 2 and 1 + 4, but only a tag space in 1 + 1. And what you see on this slide is the result of doing that. So the radical approach can be improved by putting in a few tags like the 8 in the penultimate line. Okay, so yeah, I'm not going to show
Well, I must say that my alternative proposal allows to achieve better packing ratio without such many tags and simple values. Simple values are also a big concern. You want to register 16 of 20. This is 80%. That may be too much for applications that also want to use simple values, because this must register them for once for entire world. Maybe I may show some slides.
Barry?
I have to unmute. I've just passed slide control to Vadim.
How to show this? it is. Next. For example, my alternative proposal also may use simple numbers, but only in a constrained scope. For example, as you see on this slide, a second simple zero is for application. It is not interpreted by CBOR. Then this is a template language like XSLT. Maybe done from this. My proposal goes far beyond just packing, but it also can achieve a much better packing ratio, well, comparable to CBOR packed. DNS example, and here are the problems. Let's see the DNS CBOR example. Today it was new revision of DNS CBOR draft, but as one can, somebody can see, in its previous version, it contradicted the way how CBOR pact was used, because CBOR pact does not allow CBOR sequences. For example, the inserted item must be complete array. In particular case of DNS CBOR, today's revision of draft, the specific specification of this particular case, DNS CBOR can be fixed to accommodate this. But what in the future new protocols will need this unquoted splicing, how Carsten has called this, where you need to substitute items from array without it being an array. For example, you see the example on this slide, and where it is, why it doesn't, why my well, yeah, it's a 24 slides. As you can see, the use of CBOR pact will result in this object, which is not was the original intention. DNS pact can accommodate this, but for the future protocols can't accept. Fixing this problem in CBOR pact may require even more tags, depending of what solution will be taken, if this will be fixed at all. This the array unwrapping, yes, talked. Then effectiveness of compression. CBOR pact uses 16 simple values, and about 40 tags in 1+1 range. 32 for shared table and 8 for argument. I must say this this entire distinction to two tables is somewhat arbitrary. What about this? If this proportion of 32 to 8, what is if it will be not enough for some protocols? It will. How this can be changed later. And CBOR CBOPT, due to another format, allows in its current version more than a half of what you can get from 1 byte. In exactly the same 2 bytes introduced, it uses some of the unused CBOR start bytes. So this is much more. So this will achieve better compression for more real-world documents when the number is not so high, but higher than about 30. Then I think that CBOR Pact has a fundamental flaw in its architecture. That's it uses text for everything. It tries to stay the CBOR, and this leads to unnecessary expansion. While many say that compression is not the primary goal of CBOR Pact, nobody says what exactly it's comparable to other goals. How much compression is acceptable, how much is not, so on. What I want to say is that my alternative proposal allows about the same ratio without all this text and simple values registration. Essentially, if you compare to CBOR Pact for free, very cheap. Yes, it also allows semantic compression without the most aggressive compression, but it also simpler in some aspects, as CBOR Pact requires you to use argument table for only prefixes or suffixes, and CBOR allows you to use your semantic substrings in any part of the string. Encoded just scans and so. So simple values. If CBOR Pact will register 16 simple values, then they will not be available to any other applications. Also, CBOR Pact suffers from extensibility problems already, as we can see with DNS CBOR. And CBOR is very extensible. Just define your new functions and go with the bazaar style. So about tags, well, you can see this on the slide, and I can conclude that my proposal can do everything CBOR Pact can and more. So why do we need to stick to CBOR Pact at all? It fits into the requirements of CBOR Pacts well too. That's all.
Okay, I think we need to take the discussion of this proposal to the list. And let's do a quick thing here. We have Karsten's version of how to solve the plethora of tags problem. We have Rowan's version of how to solve the plethora of tags problem. Karsten, will you quickly, in say 30 seconds, explain why you think your way of solving it is technically superior?
Are you talking about simple values or about tags?
Tags.
Tags. So basically, we are not that far apart. So if we can't do allocation of these thousands and thousands of tags for the reasons that Joe has pointed out, then we will probably do a form of the radical solution. And the only question is, do we throw in some tags or don't we? And I think I have some numbers, which I think argue a little bit for spending a few tags there is worth it. But yeah, I probably need to write a longer mailing list contribution to explain this. So we're not that far apart. The other question is about the simple values. And well, the original design of CBOR had those simple values. That's why I just took in what we had in 2013 before we tried simplifying things to actually get an RFC. And yes, we haven't re-examined the simple values question, and we probably should. But I think spending a significant number of them is okay for a mechanism like CBOR Pact, which has the table setup mechanism to allow a lot of different usages of these simple values that have been allocated to CBOR Pact. But that's maybe another long message to the mailing list I have to write.
Okay, so this goes to the mailing list. Let's set a goal of resolving the path we're going to take on this on the mailing list before the next call, so that we can. Yeah. Okay. We now need to move to the EDN literals item.
While I'm switching slides, maybe you can do a quick
Barry,
comment.
could we please just do a show of hands if we could move forward with a single tag for using the radically reduced approach? We could use that as a start. As Carsten said, that would be one wasted tag if we decided we wanted to go and add more, more tags. But
the problem is that it will be very ineffective in this case. I understand why Carsten.
In terms of compression?
Yes, I perfectly understand why Carsten took this many simple values and tags, because without that it will be very ineffective.
Right. Just for timing purposes, we need to take this to the list. And it sounds like, Rowan, your proposal is not as straightforward to people such that we could do a raise of hands right now. We need to have a discussion on the list.
Okay.
Okay, moving on.
Okay, let me try to find. Yeah, so we are pretty late, so let me just skip a few slides here. So we have the EDN literals document that does two things: define EDN in ABNF and add an extension point. And one question that came out on the mailing is, should we do both at the same point in time? Let me just summarize the discussion in one slide. So this is JSON, actually. And when we write JSON parsers, we don't pay attention to what's in the strings. So you don't have to add something to your JSON parser to be able to actually write a URI or IRA or write an IP address or write a timestamp in there. So we let the JSON parser do its work and then hand these things to the application, which will do something based on its requirements. Rohan, you're in the queue.
Yep, and that's a bare double quoted string. For bare double quoted strings and bare single quoted strings, I agree with you. That argument does not apply for app strings, because the idea of an app string is that it has semantics.
Well, these have semantics too.
Your argument is completely inappropriate in that case.
Okay, I'll just go ahead and not ask why. Okay, yeah, let's skip this one. We can do this on the mailing list. We can skip the other interesting questions as well. let me just point out then that when we are through with the discussion that we're having, we have two more technical changes we can look at. One was the question whether we actually want to have the curly brace \u escapes, because that loses cut and paste compatibility from EDN to JSON. I think that's an interesting discussion, not one we need to have now. And the other more interesting one is that maybe we actually want to have extensions with structured content. So we can have something like an encrypt with two parameters, and that encrypt application extension would take the two parameters and do something with it, like use the first one as a key and the second one as the plain text, and generate ciphertext out of that. There also was an observation that this, like the existing double angle bracket mechanism, thanks, Joe. So we can, like the existing double bracket mechanism can be nested. We would, of course, allow nesting on these as well, like we allow nesting of arrays and maps. And Andy Newton did a nice thing here because he pushed the document back into the working group. So we are actually free to make these changes because it's a working document again, and we have to do a second submission anyway. Okay, so that is something where I would say that's actually worth it. So let's just put it on a slider for itself. So you would be able to register these tags like encrypt or app1 and describe what they are doing with their parameters and generate something that goes into the data tree like it did for application extensions before, but those only had strings as input. So I think it would be pretty rational to do this. So I'm just going to jump ahead a little bit and assume that we are going to do this. And based on that, I'm actually making a proposal here. So we could just get entirely rid of the EDN literals mechanism, of the app literals, and just say we are going to do this with these double angle bracket things. So DT application extension would just take a string that has a date in it and convert this into tag one style timestamp. So once we do this, the discussion we were having is gone because we are essentially at the same level we are with JSON. So we just have a way to indicate to the EDN processor that we want to have this mechanism applied to it. I think we could agree that, and that would be a good way forward for me to solve the layering issue. Of course, H and B64 stay as they are. They're not going to change those. But we are just doing this zero or more argument mechanism for everything else, which kind of yes, no. There was a mailing list discussion about this, so I don't know if you do a search for a double bracket, whether you find it. But depending on the temperature in the room now, I was going to write this up next. So this is solving the problem for me. There's one remaining problem, which is we have a few of those app extensions that where it really helps if they are short. And a particular one is the E thing. Yeah, that's Ori's question. And the idea would be that we actually add a shorthand for text-only content. So E less than quote HKDF quote greater than could be written as a shorthand as E quote HKDF quote. And then the existing drafts can continue to use the EDN literals mechanism that they are using for getting their numbers out of the CTDL. So that would be my proposed way forward.
Yeah. So one of the problems with this slide here is that the double bracket, double angle bracket encoding implies a B string, and a lot of the usages for example, like ref, these could turn into integers, for example, right?
Yes.
And so that would change the semantics of double angle bracket to be.
Yeah, but EDN literal already changed the semantics of single quotes. So that's exactly the same thing. DT gives you an integer.
But there was a description of this, H, yeah, sure. But you're now, so I think you're taking one problem and adding another problem by saying that all of a sudden the output of a double angle bracket can now also be another type, rather than fixing a problem by doing that.
Yeah, but again, that problem was part of the original EDN literal proposal, so it's not a new thing. And a single quoted text in, let's say, Diagnostic Notation Classic is one that returns a byte string. And that is being changed.
You're just repeating yourself, Karsten.
Pardon me?
You're saying that it's not, that it's just the same. And I'm saying
yes.
It's not exactly the same because you're adding it to a new identifier type. We disagree on what the significance of that is. We can let it rest.
So I think this is a super exciting topic. I think I sent a message to the list basically asking, if there are these app strings and EDN literals that are holding up other documents, like, wouldn't it be nice to just define them as they're being used, ship the document, and then have more time to discuss this, exciting topic of like extensibility. And I like the idea of, prefixing these structured content. I think it's exciting, but I would fear that just switching out app strings for structured content in the context of this document still doesn't help us finish the document with the app strings that are depended on by other drafts. So it was really just like a, how to finish the EDN literals for the app strings we know people use, and then how to have more time to discuss general purpose extensibility, just as a procedural approach to kind of, move faster. But it was just a preference. So I just wanted to say that here because, emails are not always interpreted as you intend. Thanks.
Did I correctly hear that the problem is that text string versus byte string? If so, that then application prefix could be just changed to something with another punctuation symbol in it to solve this, for example. Or maybe this could be not 2 but 3 angle brackets to denote text string. Many ideas can come. It's probably a question to Rohan.
I'm sorry, Vadim. I didn't. So what I heard you say was, is this a question of text string versus binary string? But so what I pointed out is that for example, I could have something. So DT single quote and a date converts to an integer. Previously, a bare double angle bracket converts to a binary string only. In fact, like one of the main uses of it is to add the B string type and length to the beginning of something that's otherwise a complicated, uncanonicalized array or map. So it's not about text string versus binary string. It's about the double angle bracket currently means you're going to get a B string there. And this changes that so that based on the app prefix that you would end up with any arbitrary type. You could end up with an integer, you could end up with a text string, you could end up with a binary string. And so that's very difficult for things like, maybe code coloring might have a problem with this. I don't know, because there's no ABNF, or there's not a lot of detail. I can't really evaluate that. But it's like it's taking something where previously we had sort of like what I called an original sin of we could have single quoted app strings that could turn into multiple types, and now we're adding yet another thing that we can add multiple types to. Karsten doesn't think that's a big deal because we already had the original sin. I hope that explanation helps.
Well, I think if I understood correctly, we can invent some syntax for this to solve. As I see on the chat, maybe well, from the other side, is that a big problem? When you see an application defined subdocument, you need this application to parse this, right? Or you need to know right away into which major type item it will be serialized. Is it that your concern? If you have a generic parser and you don't know how to parse this application-specific string, then how much you can to do at all with this entire EDN document?
I think that was a question for Karsten, right?
Oh, okay. If you extend the syntax, you have extended syntax. So trying to do this in a forward compatible way is essentially impossible. So we already have accepted that we are going to extend the syntax for various things here. And application literals were one of those places where we are extending the syntax.
If the question is how it will be for generic parsers that to this item it can substitute, then being that text or binary string, then they can just put like in Python 3 quotes or 2 quotes. If not, then you need the application-specific parser anyway.
Okay, we are pretty much out of time at this point. We have stuff to discuss on the list and bring back on the next call in 2 weeks if we still have unresolved issues on them.
Yep.
Let's have a
Barry?
discussion. Yes.
I just wanted to bring attention to a message I sent on the lists during the call, and also put in the chat here that there are 4 small things related to bare single quoted and bare double quoted and double quoted strings that I think we might be able to get rough consensus. I think that we might already have rough consensus on.
Yes, I saw the post. Yeah.
So just wanted to highlight that to other participants. Thanks.
Okay. Let's have fruitful discussion on the list and come back with everything resolved. Thanks for coming, everybody. And Marco, thanks as always for taking notes.
Thank you.
Thank you.
Thank you.